Hello, DLF. I'm Jason Clark, lead for research informatics at Montana State University Libraries. I'm going to talk through this Learn DLF session on algorithms as data, a case study for turning algorithmic user experiences into research data objects. A note about what's ahead. So I want to give a little research update just about where things have kind of settled on a particular research thread that we've been pursuing around algorithmic awareness. And really what that thread has turned into a question of how do you move beyond definition and into practice. I'll talk a little bit more about algorithmic user experiences as we understood them. And then the core of this will be looking at how might you think about broad audit techniques for proprietary algorithms. And then I'll touch on some research implications. So the research itself was LB21, Laura Bush, 21st Century Training Professional Development Program under that set of grant funding. And we looked at a number of ways that algorithms shape user experience and really tried to define what algorithmic awareness might look like. A lot of that work looked at how do you document first principles of algorithms, how might you think about writing? What does a common set of rules of algorithms look like in pseudocode? Those were really useful. We came towards a pedagogy for the algorithm and thinking of how do you introduce these concepts? How do you build algorithmic awareness? So things like start with a material consequence with a person, introduce those first principles, not math, not the formulas, not the kind of coding rules. Demonstrate how that algorithm could work in action, and then leave space for discussion. But even parts of that research were fun and fascinating, and but there were pieces of it, threads of it, that felt kind of unfinished. There were moments where the algorithm itself felt still kind of lacked some transparency, even as you're starting to build awareness around it. I kind of thought of it as a ghost at times. So the question that I started to ask with this next bit of research was, what if you thought about algorithms as part of an open data continuum? How might you build, kind of codify or make visible those results so that you could analyze them? And as we came to this next question, really looked at what is the user experience of algorithms. And it could be any one of these things and more, that the way that people experience these algorithms. Anything from like, how do you search? How do you parse? How do you, how does machine look at natural language and process it? All of those things. So the question really became, how do you quantify it? How do you turn that into data? And we really needed a use case. And so what we started to think about was a particular algorithm that a number of us had experience with, and that is the YouTube algorithm. You can see that that's an algorithm that has impact within that application, but just globally, just trying to understand that. But again, proprietary and largely invisible. But there are impacts that we can record in that exchange, or in that user experience of the recommendation algorithm. So just as an example, here's a query. I'm logged in as a profile, so there's a sense of data behind this. But you can see a kind of vanilla query for algebra leads to a number of things like some SNL skits, who's getting rich off of lumber prices, best acoustic atlas intros, acoustic guitar intros of all time. So again, there was some trying to find ways to actually analyze and quantify this experience. And that's what I'll focus on in the last bits of this introduction. So the case study is really setting up software and scripting to understand and classify YouTube search recommendations. A note, a nod to a number of research partners. These were students that helped guide parts of these questions. So Marielle Karinga, Julian Kaptanian, and Tyler Bass. So when you first make this, obviously you need some kind of proprietary algorithm that you want to ask questions of. That's a first step. But then as you move into this analysis and trying to quantify what that experience is, you need to simulate some kind of user agent. All of this code is in the GitHub repository under the Algorithmic Awareness Grant. There's a place called Audit Tool. The links are in these slides. So I'm just going to mention that the first place we go with this is some kind of web scraping profile. You're pretending or mimicking a user agent. So like somebody or a machine, a browser that's going into the YouTube search and working through, running a search and then getting those results. Within that web scraper, there are ways that you identify the actual results, the recommendations that were part of that search. And that's really where the analysis will happen. And that's where you start to think about how you quantify these experiences. But first step is just understanding, setting up a web scraper that's going to be able to run a search. That's this web scraper.py. Then these examples are in Python. That's the language I work in right now. So you build this user agent that's going to go in, run the search, and collect the recommendations. The step two is taking a closer look at those recommendations. So in that web scraper, it scrapes the HTML, stores them, and then passes it to a second script called analysis.py. And here's where you start to see what you're trying to do is think about what am I looking at? How would I judge the quality of this recommendation? What is the, as it's sorting me into a profile and giving me recommendations, what do those objects look like? And there are certain tells in a recommendation that our group started to recognize, things like lots of links, big capital letters in your lots of links in the description, big capital letters screaming at you, acoustic guitar solos, awesome, that sort of. So there are a number of ways shifted. Also, a quick shift from the analysis, the query, the kind of stemming of the query itself. Like that query you saw me run was about algebra, and somehow I'm getting shifted completely subject in a topical way away from that initial query. So there are ways to start analyzing and deciding on, is this a good recommendation? How does it move? How is it changed? So all of that is kind of brought into this analysis from the web scraper to the analysis.py. And again, just to remind you what that initial query looked like. So you can see here the top 20 acoustic guitar intros. That's a screaming at me. You can't really see behind the HTML. There are descriptions for the recommendations, and those are very they give you some tells as well. Again, like if you see lots of so what we were trying to do is understand the quality of the recommendations and when the recommendations had shifted away from the initial query. And that was a way for us to understand how that experience was mediated and was it a good recommendation or a bad recommendation. So step 3 was actually taking those findings, those results, and putting them into structured data for reuse. So from the web scraper to a quick kind of rudimentary analysis about the quality and the values, the experience of the algorithm, then packaging those findings for a particular set of reinterpretation or reuse. And I think it's important to think of all 3 of these steps as you start to audit these proprietary algorithms. The standards we used in that would be things like schema.org, where we identified it as a data set, set up the recommendations, encoded them as a particular kind of data feed. But we also looked at this, there's a row crate, research object crate metadata specification. It's a newer packaging protocol that allows you to pull together not only the kind of metadata around a particular data set, but also the results themselves, the findings. So in the meta world, and thinking through how do you do this in a broad way. So think about when you're auditing an algorithm, find that experience first of all, and that could be the Facebook algorithm, it could be the Amazon search algorithm, it could be how TikTok recommends things. Any of those, as long as there's a web profile or a way to spider that with a web agent, that's the first thing, is think about your user agent and the profile you're going to bring into that interpretation. Then map out your harvesting data points for that web scraper. We had to identify the HTML that we wanted on that page after the search was run, so we could pull out data. Then think through your next step is some kind of analysis script that's going to take a set of questions and sort of run them against the user experience, the quantified user experience that you've scraped from the HTML or from that data source. And then finally, putting that into a format that can be reused and understood outside of your experiment or audit. So what does that mean for as far as where we go from here? As we think about algorithms, so algorithmic awareness was a first step. Oh yeah, and something's happening as I'm moving into these environments. I think people are starting to become more and more aware of that. But how would you then move towards turning that algorithmic user experience into data? So all of these things are the implications for, it allows you to prioritize these hidden experiences. Like there's a sense that something's happening, but it's kind of behind the scenes. So how would you pull that forward and actually ask questions of the quality or the experience of an algorithm? It's very much moving beyond just naming and defining, which is an essential first step, but moving beyond that. The auditing tool is available in this code repository. It's GitHub Algorithmic Awareness grant, but there are a couple other things there. There's an algorithmic kind of X-ray app where you can run a search and then see what algorithms were working behind the scenes. There's also curriculum syllabus and other teaching resources if you're interested. But the focus of this Learn DLF workshop is that auditing tool. We can talk more about it in the Q&A. A note and a nod to a number of people who inspired this work. The as data modifier is clearly from the collections as data folks, and I'm very thanking them for introducing that concept. Once you start to pull that apart, you can think of a lot of things as data. Also, Dr. Sophia Noble and her work to identify how these algorithms have social reach and impact. And then finally, units like the markup, which is a data in journalism, it's investigative data journalism. More and more of these entities are coming forward or are becoming just becoming not available. Just they're new kinds of media organizations, and they do incredible work, and it's inspiring to kind of pick up data journalism and pull it into our environment. Just a note, this policy happens. This was last spring. Our government is starting to think through the impact of algorithms as well. So that's where we are as far as the. I think we'll have a Q&A, and we should have a chance to talk a little more. I can potentially talk about other forms of scripting and any other questions people have. But for now, I will say thank you, and I will talk to you all soon.